Hello and welcome to the latest webinar by Bit Gardener. My name is John Kowalski. I'm part of the marketing team here. I'd like to welcome you. This is one of our 60 minutes presentations. Though 60 minutes is in the title, it's only going to last about 45 or so, with hopefully some time for some Q&A after the fact. During the presentation, if you do have questions, please log them in the chat box located in the bottom right-hand corner of your screen, and we'll get to them time permitting. If we do run out of time, we'll follow up with you directly. Our speaker, Mr. Andy Stummer, he's the director of VMA-Getzmann here in the US and Canada. Either him or someone on his technical team will get back to you to make sure you have those questions answered. Also, we are recording this, so immediately following the presentation, you'll receive an automated link to that recording. Feel free to check it out later, take some screenshots, share it with colleagues, whatever you like there. Also note, if you do have questions come up after the fact, you can simply hit reply to any of the marketing messages. It'll come to my team and we'll route them to the appropriate technical specialist in your area. Andy, how are you, sir?
I'm doing great. Thank you, John. I saw we have quite a good number of people on today.
Yeah, so, definitely.
Great,
definitely.
Great. Welcome, everybody.
Yeah, thanks for sharing your expertise with us. And it is all yours, sir.
Always a pleasure. Thank you, John, for organizing. Welcome, everybody. Today, we talk about the new innovations in production, dispersing, and milling. So we're going to cover a number of different topics, starting out with an agenda, going through the introductions, who VMA is, and then we're going to dive into a quick overview on the dispersion process. And then we talk about the different types of systems that we offer, and a little bit about the lab units we have in Wallingford, Connecticut, our high-end dispersion lab, to showcase different types of equipment. So here you can see this was at the European Coding Show a few years ago. This is actually the VMA booth. You can see there's already some equipment on display on the right side. And VMA is known to offer really high-end laboratory units. That's how they got started, as you can see on this slide right here. And then they branched into offering pilot units and then all the way up to manufacturing and production units. So here we see the product line, starting out with the smaller lab units, and then we go up all the way to lab and production. So with that, VMA was actually founded about 50 miles east of Cologne, Germany. It's kind of in the center of Germany by this beautiful couple on the top right, way back about 50 years ago, already over 50 years ago, by Hermann and Elke Getzmann. The relationship with BIG dates back about 40 years, since 1988, and we are the exclusive distributor for the VMA-Getzmann product here in the US and Canada. The company is still in family hand. It's run by Christ and Martin Getzmann. They have about 100 employees globally. And VMA is known to be a high-end manufacturer of dissolvers, bead mills, basket mills, like I mentioned earlier, for lab space, pilot, as well as manufacturing. The unit on the bottom right, you can see it right there, is actually the first Dispermat was created way back in 1973. And believe it or not, we still have customers that are still running on the original units today. So these are brushless step motors. They hardly break. I mean, I've been with BIG for going over 20 years now, and we have never seen a single broken motor. The shaft goes right into the motor. They're super quiet. There are no belts or anything that need to be replaced. So they work beautiful, and they will last a very, very long time. And customers are very happy with this technology generally. So we have the company here on this picture, the building right in the middle. Actually, I don't know if you can see my cursor, but that portion in the back that was added on, closer to that riverbank right there, and that was added on about 2 years ago to increase production capability and design capability. So there's a lot more floor space. They added also another level to that building to really ensure that they have all the capabilities they need to design and produce this equipment. 40% of everything that VMA makes is custom. So there are a lot of new end-use markets. Just think of fuel cell or battery comes to mind. So the VMA philosophy is to really be able to quickly accommodate those different requirements with different materials, or just think of a vacuum system that now needs a nitrogen purging port or a port for inert gas. So they're able to make all these modifications really quickly and design systems really for this new end-use market and customer needs. As I mentioned earlier, we have a really nice dispersion lab here in the US in Wallingford, Connecticut, right next to our sister company, Big USA. And then we also have one in Germany. We're going to cover that towards the end of the presentation, show you what kind of equipment we have up there, and talk a little bit about these capabilities that help customers make good informed decisions on what to buy and why VMA is such a good product. The dispersion process, which is going to cover really briefly, what are we really trying to do here when we talk about dispersion? It's pretty much a very simple thing. All we want to do is break up these larger agglomerates, these particle clusters that you can see, and turn them into aggregates. And then ideally, we want to make those aggregates, we want to bring them down to primary particle size. And we use a dispermat to accomplish that by shear force, introducing shear forces, and then basically are able to break up these invisible van der Waals forces. They're called these electromagnetic forces that hold these particles together, and then break them up, and these agglomerates turn into aggregates and then primary particle size. And then finally, we need to stabilize these particles in solution by using a different additive, depending on the formulation or the end use, to stabilize these materials with different additive packages that Big USA offers. That is also very critical. Different dispersing agents, deformers, and so on. So I really like this picture because it kind of outlines and shows what is actually happening in the dispersion process. So first, we use a cow's blade, or some people call it impeller blade or dispersion blade, to wet our particles and to really introduce the shear force needed to break up these agglomerates. Then when we reach about 10 to 30 microns of particle size is when we actually start the media milling process, because the blade can only bring the particles down to a certain size. It doesn't allow for more shear. So that's why we need to use a media mill to then break down the particles to smaller particles below 10 microns and go even into the nano range. And then again, we want to stabilize these products with the right dispersant agent. And you can see right there on the right side how these particles then really neatly stay in a suspended state and don't flocculate back together. So that is really the goal of the dispersion process. We don't want to destroy particles. All we want to really do is break up these van der Waals forces, make the particles as small as possible without destroying them, and then really keep them in a suspended state. That is what we are after. And that is, in a nutshell, the dispersion process. So here is just a cool slide showing you the different types of pigments under the microscope, TiO2, and you can see yellows and black. So what that looks like under a microscope relative to their particle size. So on this slide, it actually kind of shows you at what point we are moving from a dissolver over to the milling process with using a bead mill. So again, I said 10 to 30 microns. That's the rule of thumb. And we have customers that actually use a dissolver to go to 5 microns, but that's relatively rare. Most of them end up anywhere between 10 to 30 microns. And at that point, we move over to the bead milling process, either using a horizontal bead mill a vertical bead mill, or some people use a rotor stator. So there's many different options on how we are able to reduce the particle size depending on the application. I really like this slide because it kind of shows exactly the efficiency, the dissolver, and then obviously there is this point of diminishing return. You can keep using a dissolver, but you're not going to be able to bring down the particle size. So that's what the point when you then move over to the milling process. And we have some bead mills in some different setups with different setups to go actually way below 100 nanometers. So there are applications for solid state batteries, for example, where we have to go below 50 nanometers with the bead mill to achieve the desired particle size. So in a nutshell, the dispersion process is always two steps, right? So first, when we talk about the pre-dispersion process, we talk about using a dissolver. So that's done with the cowls blade. Very critical there, we want to have a tip speed between 18 to 25 meters per second. That's the speed of our blade. So it's not interesting how fast the RPMs are and so on. A lot of people always look at how fast are the RPMs. That's only one component. We're looking at the actual tip speed. That's the speed of our blade. Needs to be between 18 to 25 meters per second. We use a dissolver. And for production, we have the Dispersion line SC. We cover that in more detail a few slides later. For milling, it's fine dispersing, grinding. Our tip speed is 10 to 16 meters per second. So you can see quite a bit slower. And for that, we need to use either horizontal bead mills. We have basket mills or vertical bead mills. There's some people refer to them as pot mills, like our APS system. And then for the basket milling, our TML system, tourist mill, SK, and also the quick change system. With those systems, we're going to cover it, giving you the ability to move quickly between a dissolver to a basket mill. And then we have the horizontal mills, RS5, RS10, 20, and 30. They are our answer to the horizontal milling question. So there is many different applications, where dissolvers are used. So just here are some examples, dyes and varnishes. Obviously, it's coming out of the pigment world. So every coating company out there, or companies that make chemicals, additives, like our sister company, Big USA, inks, plastics, construction chemicals, electronics, different types of adhesives. They want to use vacuum systems, all sorts of coatings, marine, construction, architectural, pharma, cosmetics is another big one, agrochemicals, 3D printers, way too many to list. These new end-use markets I mentioned earlier, fuel cell, lithium-ion batteries. So they are all applications where people would use this type of equipment to produce really good results. So this picture here was actually taken at a manufacturing site in Europe, and you can see the Dispersion SC is on display, and it shows you actually the same machine with different heads. So that's kind of like the philosophy behind our design, is that a customer should be able to use one equipment for many different applications or steps in the process. So you would buy, let's say, a Dispersion SC. It comes a dissolver, but it also has a quick change system on top that will then allow you to very quickly move over to a basket mill that you can see right in front, right here on the right. It's the same machine with the basket mill. Then you see it with the dissolver, then again with the basket mill. And then in the back there, it's the same machine, but it's closed. It's basically in operating mode, showing you what that would look like when the machine is actually running, dispersing or milling material. So that's the beauty of the Dispersion line, is the modularity, giving you the freedom to do many different things with one machine. So here you see the Dispermat SC. Obviously, this is a relatively small container. We can go up to a 2,500 liter container and as small as a 50 liter container on that particular model. So 35 liter of product volume, all the way up to 2,000 liters of product volume. And maximum output 55 kilowatts of power. So they really produce a good amount of energy to disperse or mill your material. So that quick change system that I mentioned earlier that you saw in this other picture is actually patented, and we are able to do that relatively quickly, to do the changeover. So we can turn the dissolver over to a mill in less than 5 minutes, which is super quick. The big advantage there is that customers don't need to buy multiple pieces of equipment. Now you can say, hey, I can buy one machine and I can buy, let's say, a number of different basket mill attachments, dedicate one basket mill to different color families, and then have them, just put on depending on what color I'm running. And I can make that swap over in less than 5 minutes. That means I don't have to tie down my equipment for long periods of time for cleaning. That basically is wasted time. I won't be able to run material. So this way you can do a quick flush of the basket mill, a solvent flush, or just rinse it out, and then put it on a trolley and then replace it with another basket mill for different color families. So that way you're always running and really saving time and money in the process. There is the ability to also get the vacuum cover. So some people like to pull out air. That's a big advantage for some applications. We'll talk about that in a little bit. And then the cover is also removable. So you can take it off very easily or lift it up higher than normally if it was fixed to the shaft. This has a pneumatic lift system. That way you can actually lift up the cover to a higher position that gives the operator access to the bottom of the cover for cleaning purposes. So that is a big advantage of the design of the machine. Some viscosities are really high and require a wall scraper, so that is also an option. And then we offer the explosion-proof versions where needed for certain applications. So that kind of shows you that quick change system. So we start out as a dissolver, and then very quickly we can throw on a basket mill on the same machine, or even a rotor stator is an option as well. For some applications, people don't always want to use media to mill, so they prefer to use a rotor stator. And then we also offer them with different types of materials like ceramic. There are customers that, for batteries, ceramic is really important. You don't want to bleed in from the metal into the electrolyte or the barrier coating, so they have to use zirconium or some type of ceramic. Silicon carbide is another option we have. Or if customers are milling a lot of white material, you really want to have a ceramic, so you don't want the bleeding of the metal into your slurry, turning it gray. And we have seen that happening, so that's why we offer the ceramic options for these type of products. So then we have the SC with vacuum. So the vacuum is actually great because it pulls out the air, allows you for a more homogeneous mixing or milling process. So I get a better wetting and dispersing effect. I'm able to put in more energy. Think about it this way. So the air bubbles in the content in the slurry, they almost act like they're like little life vests. Think about it this: you're wearing a life vest, and somebody came up to you with a boxing glove and punched you while you were wearing the life vest. So that life vest would obviously, cushion the blow of the punch. So when you take off that life vest, the punch will be a lot harder. So that's kind of like what's happening with the air entrapment, the air bubbles inside of our slurry. So when we remove the air, the media, the beads have much more access to the particles and are able to put in more direct energy. So that is the advantage of removing all the air. So you're also able to take out all the foam. If you don't have air, you don't have foam. So you can cut down on your defoamer if you're using one. When the product is finished, you're able to transfer the product much quicker to other containers because you don't have any foaming. So it leads to improved homogenization, obviously cost savings because you should be able to mill quicker, cuts down milling time. There are different types of vacuum pumps depending on how much vacuum you want to pull. And obviously on the container size, if very large containers, we obviously need a more powerful vacuum pump. And then optionally, we offer the ability to add this nitrogen purging valve or any valve for different inert gases that some people like to do that or mill in a dry environment. So that's why they want to purge with nitrogen. So that is always an option as well that is installed on the cover. So here is an example of a machine we built for a customer. This was just a dissolver, but you can see right there it has the vacuum cover on it. I believe that was a 1,250 liter container. We have the ball valve in front that can also be a flap valve. The containers are also machined with the highest precision. If you look inside, they're absolutely perfect. They can come in double wall or single wall, depending, if you're milling, you want double wall for cooling. If you're just mixing or lightly dispersing with the blade, you might get away with just a single wall. But this is optional. And you can see the vacuum cover here up close. There are different ports. So in this case, we have a product feeding port. So customers can use a funnel or a hose that attaches, and then you're basically sending in your material into the disper mat without it being open. So there is also a light that you can have. So optionally, we can put a viewing port, and then with a high-powered LED light, you're able to actually see what's going on during the dispersing or milling process. So high-quality machining, and here you can see a smaller one that's more for a larger pilot unit. And there you can see the different valves on top of the purging valve. And then you have obviously the viewing glass right there in front. Here on the side to the left, you have a port also for adding material. You could either add a funnel or you go directly in via hose and add your material that way. So this particular cover also has a scraper. I can see that because behind the main shaft, you can see in the back, there's this blue motor. That actually is what drives our scraper arm. The scraper arm can be replaced really easily, and the scraper is needed for high viscosity. So if you have product that sticks to the container wall and you want to really get everything removed and make sure that everything gets pushed into the middle of the container for proper dispersing, then you really want to have the blade or the sweeper blade for these processes. Here is an example of the SC, that one you saw earlier, the customer unit. This is the switch cabinet. So that houses all the electronic components, switches, everything, frequency inverters, so everything that the machine needs to power up is actually inside of this box. This is not explosion proof. So when you have an explosion proof model, this would be installed outside your EX zone. So you would need to run a cable long enough to go from here over to the disperser, and the power that comes into the building is ideally close to that particular switch cabinet. And that's basically the control unit of the electric control unit of the disper mat. We have different ways of actually running our machines. So on the right, this is kind of like the standard production dissolver panel. So very simple, just the standard buttons. Safety is really critical. So in order for somebody to operate the machine, both hands need to be on the panel. So if you want to lower the cover, for example, you need to have both hands on the machine and turn the knobs with your left and your right hand. That these knobs, like on the bottom left and the bottom middle switch, they need to be turned. So you need both hands to lower the cover. That way, we ensure that the operator cannot have his hands in the middle between the cover and the container lip, so it wouldn't get crushed. So this is a very easy way of running the Dispermat. Very simple. All the critical information is on the display. The amount of amps we are putting in, power, and our RPM, and also temperature readout. We have the emergency safety switch right on the front panel. You can see that to the right, and that basically allows for a very quick switch off of the machine if needed in case of an emergency. On the left side, we have our C technology panel. The C technology gives the operator a lot more processing control and visibility to the different dispersion parameters. So you can see on the top, we have our RPMs. Then right below that, 2,380, that's our watts, our energy input. We know exactly how much power we need to disperse or using to disperse this material or mill it. We also give you a torque value. That's 4.1. That's on the bottom left. That's an indirect measurement of our viscosity. So some people really want to know, hey, how is our viscosity changing during the dispersing or milling process? So by having a torque value, I'm able to see that really clearly. We also, on the standard machines, express the torque value obviously in Newton meters, but it's a calculated value from the frequency inverter. We have a TMS sensor, which is basically a special sensor that's ordered separately that goes onto the shaft, and that actually measures, now calculates the torque value directly on the shaft to a resolution of 0.1 Newton meters, which is extremely precise, and customers use it to create their own viscosity tables, and they can be done in the lab as well as pilot and production. So that can be really helpful, especially if viscosity is really, really critical for your process. On the top right, we show you the actual tip speed, the peripheral speed. Remember, we said when we are dispersing, we want that value to be between 18 to 25. And when we are milling, we run that with slower speed, 10 to 16 meters per second. Temperature readout right there in the middle, 42C. We can change that to Fahrenheit, and then we have a timer function as well. Now with the C technology, I'm able to also program what is called cutoff values. That means if I have a product, let's say that's temperature sensitive, and you don't want it to exceed a certain temperature point, then you can program it where, let's say 80C would be our cutoff. Then I want to be warned at 70C, and then I want to get a second warning at 75C. So I can program that. And then at 80C, the machine would either cut off or run with a different speed or different energy input. So some people say, okay, I don't want to turn the machine off. I just want it to run with 20 or 30 RPM. So at least it's mixing while the material cools down. So that's one way of protecting the material from overheating, these cutoff values. I can also run this this machine, if it has the C technology, with constant power. That means in this case, you can see that red dot right next to the 5,500 RPM. That means I locked in 5,500 RPM. I can also lock in the power instead of the RPM. So that means I could lock in, let's say, 2,380 watts, and then the machine would automatically adjust the speed depending on the change in viscosity of my material. So if my viscosity increases during the dispersion or milling process, my speed would decrease if I'm holding the 2,380 watts. If my viscosity decreases, then my speed would automatically increase if I'm running with constant power. So now that means that I'm now able to calculate how much does it really cost to produce that material, because I know exactly how much energy it takes to make that product or mill it down to a certain particle size, and how long did it take to get there. So that will really be beneficial to the people that want to calculate those costs when they can run with constant power. You can obviously run with constant speed, then also the energy will automatically adjust to always maintain that speed. That's just what we know from standard dispersers and mills. So not any different than that. You can also program recipes with the C technology, allowing you to lock in all these values and then basically give the batch a name or an ID number. And then the next time when you're running this product, you're able to replicate it exactly the same way for consistency and repeatability. So that way you can be sure that the product will always be produced the same way, and that the particle size and everything should be constant if the process remains the same. So that's a big advantage of the C technology. Then we have this programmable control panel that's made by Siemens, and this basically gives you the option to program it the way you want it, integrated into an entire manufacturing process. Add, for example, a scale. Some people like to put their Dispermets on load cells. So that means that now I can weigh the raw materials as they go in, and everything will be on the same display as the dispersion parameters. And that's why we have that option here with that beautiful Siemens LPC panel right there. PLC controller, sorry. We also have the pilot plant with some of these capabilities. So that's just a picture of the pilot plant in Germany, where we are offering customers the option to come in, check out some of these types of equipment. So we have a vacuum system over there, we have mills, and we have also dissolvers and rotostators, so customers can come and check out how they actually work in the real world. So then we have something really cool. It's unique. It's an amazing piece of equipment, especially for people that want to produce something quickly on one machine without having to move from one machine to another machine or do any type of changeover from a dissolver to a mill. And it's our TM version. And basically the TM is a 2-in-1. So you can see in this picture series on the top left, I put my my raw materials underneath the machine. I put my container there. I add all my liquids, and then I'm adding, my pigment or other raw materials. I'm dispersing. I'm wetting everything. I'm de-agglomerating. On the bottom left, you can see everything is properly de-agglomerated. And at that point, when I reach the right particle size, after that pre-dispersion process, I push a button on the control panel, and now my basket comes down, and now I'm milling. I never moved the container around, had to change over anything, and then when I'm done milling, I can just remove my container, and I start with the next batch. So that is a very effective way of dispersing and milling with one machine. So we have same design philosophy, motor, everything stays the same, except now I have a dissolver and an integrated basket mill. Same idea, I have different control models, explosion-proof versions exist. I have also the ability to add ceramic if I want to for my basket mill, either zirconium oxide or silicon carbide as options. And then I can also get a vacuum option also on the 2-in-1. So really awesome idea. Basically, everything is a closed system. You are pre-dispersing, then I'm milling, giving you really high quality milling performance. Very easy to scale up from the lab to production. All of our TML mills are designed to be scalable. So if I get good results in the laboratory, I should be scaling up almost to a ratio of 1:1 to my manufacturing units, and our technology allows you to do it. So that system is really cool. Now, the only downside, if I have to say, on the Dispermat TM would be that you can't really easily remove the basket. So if you have one high mover and you have one product that, let's say you're doing a white or some unique product that you're doing a lot of and you'd never change it, and you want to dedicate one machine to that particular product, then this is your answer. But if you are using a machine for many different products, then maybe this solution is not the best one, because you want to be able to replace the baskets quickly to move in between color families. So with the TM, this basket would be fixed and you can't easily take it off. There's no quick change system. So really only think of using this system for your biggest movers and product and your materials you don't change often. So that would be a perfect solution. In this case, you can see on this picture, customer bought two Dispermat TM 1000s. The cow's blade leaning against the drum in the background, they haven't been installed yet. The machine on the left, they're identical. This is fully raised up, so you can see the container is already underneath it. And the machine on the right, this is how it was delivered. So it's collapsed, and that would actually what it would look like during the dispersing or milling process. So it comes down, and that's what the height would be like when you're actually using the equipment. They're really awesome. They're workhorses. They run 24/7. They hardly ever break, so you really only have to worry about replacing your milling discs periodically, and the screen inside of the basket mill if you are milling, and also the of course the cow's blade periodically if you're using it a whole lot. They don't wear out that much, but that's also would be a wear item. Then we have standalone basket mills. Again, you can buy a basket mill if that's what you want, but you can also get the quick change system with the SK that allows you then to back convert it to a dissolver. So the principle is still the same. You have that quick change system to convert it back to a dissolver if you want to. The basket mill, again, offered with ceramic. You can get a nano kit, allowing you to really mill down into the sub-micron range, and then vacuum as an option, and the quick change system for the quick color changes that is so attractive for a lot of customers. This is that support trolley that you would need to do that changeover. So I can tell you that we have done quick changes in under 5 minutes. So it's very easy to do. You don't have to be strong. You can just basically remove the container, put the trolley underneath, lower it, then basically remove a clamping ring, turn it slightly, and it comes right out. And then put the trolley, the other trolley underneath, and then you basically lock it in place and then lift it up. So a very easy and quick way of changing from a dissolver to a basket mill. So here just a series of drawings. So first, obviously, we have our container with the slurry that's already pre-dispersed, and then you just push a button and the basket comes down. You can see the beads inside of the basket mill and surrounding the milling disc, and then you're milling the material. With our basket mill design, we get really good flow of the material. So the basket mill is really designed to give you optimum flow in and out of the basket. So for that purpose, we actually installed a screen on the bottom of our basket, not on the side. And there we're basically able to remove the material in and out of the basket with that cow's blade that you can see on the bottom that's attached to the shaft, that actually has the purpose of pulling the material out of the basket and then push it back around to the top, where then we have a pumping wheel or vortex wheel inside of the basket mill to actually suck the material back into the basket, where then the milling disc and the beads will do the milling job. So it has a very good flow in and out of the basket. And the reason why we don't want to have a screen on the side is for cooling. So basically, our basket mills are double walled. So these bars that you can see here that are holding the basket, they're actually cooling channels. So we're sending down coolant or cold water in and out of the basket. So come in on the right, leave on the left. And then basically the entire basket, even the top portion, is properly cooled. This is where we put in all of our energy. So that's where we want cooling. If we had a screen on the side, we wouldn't be able to cool that portion. The other dilemma with the screen on the side is that there is very high wear of the screen in that location, because that's where the beads are bouncing, back and forth. So they would be impacting the screen on the basket wall, and that would lead to very high wear. So that's why we opted to close that off, have the entire basket mill closed, except the bottom where we have the screen, and allowing you then to remove the product with that cow's blade very efficiently to get perfect cooling and very good flow of our product in and out of the basket. Big advantage, big cost savings over some of the competitive units that are out there. But really the end goal is you want optimum cooling, and that design will give you that. We also have temperature measurement inside of the basket. So there's a third bar that's right behind those two bars in front. You can see it in the back, and that actually houses our temperature probe, the PT100, that actually measures the temperature inside of our milling basket. So that's also really important. Okay, and then here is just an example of our horizontal media mill, the Dispersion RS, which comes in different sizes, obviously depending on how much throughput you need. And we can go all the way up to 30 kilowatts, maximum of 1,000 liters per hour. You can also get different control panels like the C technology. You can get it more robust and simple for the operators. There's explosion-proof versions. We again offer ceramic option, a nano kit, and then some people actually want to use a vacuum when they use a horizontal mill. So that is also optional. And then we have our APS system, which I mentioned earlier, or pop mill. So it's basically two containers. So you have the top container is actually where you are milling the material. You can see on the bottom of that container, there's a drain plug. And there is a screen that sits right above it. So that basically keeps the bead in the container. So when I'm done milling, I actually have a socket, an air socket, or the air connection in my cover that allows me then to purge my container with air or nitrogen or any other inert gas, and then push out the material into the container below that then basically would be catching all the milled material once I remove the drain plug. So a really easy, efficient way of milling. Now, this works really good in the lab. It works also good for we call pilot or low volume production. Because if somebody is milling a lot of material and has a lot of volume, you can see that the APS system allows you to use 100% bead loading. So if I'm running with 10 liters, I can put 10 liters of beads in there. So that gives me a very high milling efficiency. But let's say I'm doing 1,000 liters, I would now need 1,000 liters of beads, which makes it cost prohibitive. And also the handling would be very challenging. So the largest APS system we made was for a container that for a customer that are using these APS systems to mill down high quality platinum pastes and expensive materials that basically would be a production run with about 35 liters. So that's why we consider it more of a batch and smaller production volume option rather than something for somebody who wants to do hundreds of gallons or thousands of liters. So this is really somebody only want to do very small, limited production runs where it makes sense, from a handling standpoint and also from a cost standpoint with respect to the media. Beads are very expensive, as you know, and ordering 1 kilo can cost hundreds of dollars depending on the quality of the beads. Imagine you're ordering 1,000 kilos. Now you're talking more money on the beads than the equipment. So this is our VMA applications lab in Germany. We have a lot of that equipment for scaling up. So you can actually go and try out everything on a small scale: basket mill, rotor, stator, dissolver, horizontal mill. And then we offer the same capability in Wallingford. Everything that we need to scale up and show the customer is available, all the different attachments. And then we added some new equipment to the lab. So we have a new AE6 with the C controller. We have a new SL horizontal bead mill. We also this year just added a new vacuum system, VL unit, and we also added a pilot scale AE unit, so a larger AE than what you can see there on the left for pilot applications. And then we also have a mock-up model of an SK production mill that you can come and take a look at. It's not operational. It doesn't have a motor. It only has the housing. It was sent over from Germany for the American Coating Show, and we have it on display. But it's a really cool piece of equipment to show customers on what the size is like and the build quality. So if you are interested in evaluating some of these different types of equipment options, the basket mill, you want to play around with scaling, then we would extend an invitation to you to come up to Wallingford with your product, and then we can run it on our equipment and show you how we can scale it and ensure that that works for you. So let us know if you have any desire to come up there, or you want to give us an opportunity to evaluate some of your products with you present, then we would be glad to set that up. You can also come up there just to see the equipment. It functions also as a showroom. We always bring in our colleagues from Big Additives to help us and support the various trials with their knowledge on additives. So we have customers come in and are also looking for formulation improvements. And then that synergy that we have with Big USA is really helpful, because these chemists can really dial in and say, hey, let's try this defoamer, or let's try that dispersing agent. Maybe we get better results. And then it helps the customer not only understanding the value of the equipment, but also having the ability to evaluate different additive packages that would not only improve the process, but also the formulation. So that's where we are unique, in that we would leverage these synergies with Big USA, and no other instrument or dispermat company or dispersion manufacturer has that type of capability. So that's a huge advantage, and customers love it that we offer that capability. So with that, I think we are right on time to close this out. I hope gave you a good overview of our new innovations and production capabilities with the VMA product line. So thank you very much.
Yeah, thank you, Andy. That was excellent, as always. Excellent. And I'm glad you spoke about the synergies we have with the additives organization and the importance of, seeing our dispersion lab running trials and, seeing firsthand. So thanks for covering that. We do have a question here. Is an impeller blade the best option for dispersion? Can a pumping or combination blade achieve the same level of particle size?
So to be perfectly honest, I don't have a lot of experience with these other blade types. So it's
Okay.
possible, but for
Mhm.
our process and the way we go about dispersing, we know that the dispersion blade is a really important part of our process. And we get really good results. So we never had the need to really look for a different option there. But if you have a drawing or anything that you would like us to explore, we'd be glad to do so. As you know, I've mentioned earlier, 40% of everything we make is custom. So we pride ourselves by having that capability, and we definitely be willing to look into that and accommodate your wishes with the different design.
Yeah, no, good point. Thank you. When a customer approaches you for a production unit, they're ready to scale up. What are there a set number of steps or things that they need to consider, prior to making that jump? Can you
Yeah,
guide our audience a little bit in that process?
sure. So obviously, first, what I would say is let's get started on trying that on a smaller scale. So come up to the lab, bring a small quantity of your material, and let's run it on a dispermat and then mill it with the TML mill in a small volume. Then we're going to look at the results. We're going to look at the milling time. We're going to look at what bead size we use, the screen mesh size, and all that. And then also the diameter of our dispersion plate. So we're going to record all these different parameters. We're going to dial in what combination gave us the best possible
Mm,
performance.
yeah.
So with that data set, we are then comfortable moving up to the pilot. And then from there, we are then confirming what we did on a smaller scale. And then when we validate and we can see, hey, how did we scale up to pilot? We have a TML5 up there, so we can do that. Then we would say, okay, uh, if we want to go production, we need to go with that size basket mill. We need that mesh size. We need that diameter dispersion blade. So the ratio should always be the
Mm.
same to what we do in the lab pilot as well as manufacturing. If
So
we
you're
do
just
that,
Yeah, you're just calculating that, pilot ratio and upscaling it to a production type unit. Is that right?
exactly. But we
Yeah.
want to be comfortable in that we produce good quantitative data in the lab to make sure that, hey, the outcome is good, and now we're going to scale that. I wouldn't just go straight to a manufacturing unit and say, hey, here, unless you know the equipment and you have used it before and you're comfortable,
Yeah.
but you want to really understand how it works with your material. So
Nice.
starting in the lab and then scaling from there is important. And there are some key things we look at, like I said, screen size, mesh size, you know, quality of, material that we use for the milling disc, ceramic knot, blade diameter, all these things. Then we talk about the processing parameters, the amount of energy we are putting in, the tip speed. All these things should be constant
Yeah.
when we go to production. And we should be able to get very close results to what we get in the lab.
Nice. Another question in here. Is it possible to use a mill with a minimum batch size of 50 pounds to 250 pounds?
Yes, absolutely. We have the H4 system. That's actually a sweet spot for us. The volume that just came up. Um, Send us an email, send me an email or John, and
Yeah.
we'll send you some information on that. But we have everything that you saw in the presentation earlier in that scale.
Perfect. Perfect. Thank you. Another question. I think we have time for one more. Are there different types of blades for varying viscosities, or does a cow's blade work for everything?
So the blade, yes. So there are different blade types, but different blade manufacturers swear by their own proprietary design. We have one standard design that we use for almost all viscosities. What we are looking for is if the viscosities increase, then we just proportionally increase the diameter of our blade, because we want to ensure that we get proper movement of the material inside of in the container. But we also want to use that in conjunction with the sweeper blade. So yes, we want to adapt the blade to the viscosity, but we also want to use for high viscosities the sweeper blade to make sure that everything is properly dispersed.
Okay. Excellent. Let's see, is there one more comment in here? Are there any other, well, I'm waiting for this to come in. It looks like someone's typing here. Are there any other here it comes. Good, I don't have to stall. What's the rule of sizing production blades? Is there any rule?
So again, we want to go with the same ratio. We have tables.
Okay.
That show you on our website. If you go to the dispersion.com or VMA-Getzmann website, there is a know-how page, and that has basically there is a table under dispersion blade diameter and container ratio size. So basically, we always look at what is the container size, and based on that, we look at the viscosity. And with that information, we're able then to go and pick the right diameter blade. But generally, what we want to do is we want to match what we do in our lab and where we got the good results. And we want to keep the ratio the same. So that is the most important thing, is that the ratio stays the same. Not only the blade ratio, but also the container ratio also stays in sync. The blade container ratio same in manufacturing.
Awesome. And I did throw that link in the chat here. It's to VMA-Getzmann's website on the container sizes and dissolver disc diameters. So check that out.
Yeah. It's an excellent tool. The whole website is fantastic. That know-how page gives everybody really good in learning more about the process and understanding all the critical parameters. We have beautiful seminars that we host on just the theory behind dispersing and milling. I don't know when the next one is, but maybe for anybody interested in those questions, you might benefit from joining us to one of these meetings or presentations.
Yeah. Also in the chat, at the kind of introduction, you'll see a link to the YouTube channel. We keep all the recordings of these webinars out there. And there's some other stuff as well. So take a look there. And also feel free to reach back out to us, hit reply to any of the automated marketing messages you receive. And my team will route it to Andy or someone on his technical staff. So with that, thank you, Andy. Thank you for sharing your expertise. Always enlightening. Thank you for attending out there. We appreciate your questions, your attention, and we look forward to seeing you on future BitGardener web seminars. So have a great rest of your day.
Thanks, everybody. And feel free, if you're in the market right now, shoot me an email. I'll be glad to sit down and talk and look at your application. We're running also some specials. We're all faced with challenging economic times. So really trying to compensate for some of these tariff increases. So working with the customer on that to make sure you don't get hit, and make sure that we provide an economically feasible solution that allows you to produce good products. So let us know, and we'll be glad to talk to you.
Yeah. Andy, I hope you don't mind. I put your direct email address in the chat here. So if someone's interested, take a screenshot of that and email Andy directly. So perfect timing, perfect webinar, Andy. Appreciate it. Thank you, everyone, and have a great rest of your day.
Thank you very much. Have a good one.